Good morning, everybody. Hope everybody's energy levels are okay. It's only, 11 a.m. at this point, right? So, so next slide. Again, my name is Alan Cheung. I am the VP of Engineering at Kiddom. Previously, I have been at a variety of places, Discovery Education. I was in management roles at Affirm, Council, and Square in the really early days. But currently, I am the VP of Engineering at Kiddom. Kiddom, for those of you who haven't heard of us, is an edtech startup using technology to enable teachers and learners, and we primarily do that by serving core curriculum in the K-12 schools, in the K-12 education space. We are a Series C startup with about 50 engineers across everything from product engineering, QA, DevOps, TPM, basically the entire gamut. And for those who are not familiar with basically the startup cycle, I wanted to kind of highlight here, you start out basically angel and seed round. It's really you just have an idea, right? You have an idea of how something, of something that you want to build, so you go ask people for money for it, right? And then you get to kind of Series A, which means that you actually start finding paying customers. Series B, which means that you're expanding into the market. And where we are, which is Series C, right? Which is that we've already found some product market fit. We are starting to think about new product lines, looking at adjacencies, looking about geographical expansion, right? And this hopefully helps people understand, at this part of the startup journey, it's when tech debt really rears its head. And very quickly, we realized that tech debt really is a natural consequence of prioritizing the speed of iteration over technical rigor in light of continuously changing product requirements, right? Like, this is why Series C it becomes this thing where, instead of pivoting and trying out a bunch of different things, it is kind of at the point where, hey, like, we found something, but we've kind of ignored, the fact that we've built a bunch of stuff that didn't work out, or we didn't build it in the best way, and now we actually have to scale out everything, and now this has become a hindrance instead of a help, right? This is kind of that inflection point where tech debt really does come in. And I want to point this out as well because a lot of times it's fairly easy to kind of, as engineers, we like to blame that the idiots before us were the ones who, kind of built it incorrectly. They didn't know what they were doing, right? They were using frameworks that were, when they were building it, we were already a decade out of date, right? And it's very easy to basically scapegoat the folks that came before us. But in reality, right? Again, because you're kind of at this point where, okay, now the quality of the code starts to matter. Now stability matters. Now reliability matters, right? Now the speed of delivery, things are starting to slow down because you're really under all this, debt that you've accumulated. That's kind of when we start wanting to tackle it, and this is the place that we found ourselves at Kiddom. So to give all of you like actually what's happening to our company right now and to our technical systems, what we ran into specifically is this idea that the original ideas of what Kiddom wanted to be was actually, we wanted to serve teacher-generated content, right? And then we found out that our real business case is actually having other people author this content, and we basically serve it. So, what that actually, from a technical standpoint, what that means is that our databases were not optimized for reads, which is what most databases are, right? Our database selection was actually optimized for both reading and writing, which is a weird case when, again, most of the use cases now are actually reads. Second point about complex documents. So previously, when we were having people create their own stuff, fairly simple, fairly small, right? You have basically rich editing functionality. And turns out our business use case, really big documents, because these are giant curriculums that we're actually expecting teachers to teach off of. And suddenly the size of their documentation, the size of the actual things that we're serving, suddenly, no longer, we actually did not build the architecture for that, right? And then thirdly, as we actually are working with bigger schools, we found out that what matters to big schools is efficiency, it is timeliness, right? It is getting their curriculum on time. So instead of teachers wanting to basically build their curriculum in their own time, no, they want it at the start of the school year. It matters that we actually deliver on time. And again, our infrastructure really was not built for this use case. And here's some of the warning signs that we saw because of that, right? Testing kept on taking longer, right? The performance, because we were not expecting huge documents, started to take a hit, right? Obviously, the velocity and delivery slowed down, again, because of all the debt that we've been incurring. And then something called employee NPS, right? Which is a measurement of figuring out how well your company is doing, how well your folks are thinking about recommending your team to others, started taking a hit as well, right? Because of the low morale. So hopefully that sets up, okay, here's the scenario in which we find ourselves. This is why the tech that matters. Here's how we're going to try to address it, right? So, full disclaimer, what we did, and then what we're still working on, right? Like, this is not done. I am very much kind of highlighting this is a work in progress and that this is what we've done so far, recognizing that there's still more to go. Break it up into kind of 4 phases here, just so that I can try to kind of go over each part. Starting 1 is our own vocabulary. And by the way, for those folks who actually do slides and presentations, a pro tip is that I started using AI to generate my clip art. It's a lot more interesting than just finding it online. And it's weird. So one of the first things we actually did was actually coming up with our own vernacular. Strong belief that you bring to a company kind of your existing processes and your experience, but you have to make it the company's own. Otherwise, your team and the people on your team will basically reject the premise of, hey, I don't want to be following this process because, hey, you just brought it in from Facebook or from Meta or from Google, right? And so we had to come up with something that felt like it was, felt like the team could actually buy into it. I was actually not the one that came up with this. I actually give credit to one of my senior software engineers, Nels, who came up with this idea of gardening, right? In engineering, I think we're used to calling things tech debt, right? And there's plenty of analogies, call it like a mortgage, something like that, where we talk about debt as this kind of amorphous concept. And we found that within non-engineering teams, sometimes that hit, sometimes people understood what I meant. A lot of times, people were like rolling their eyes a little bit, saying, hey, you say this all the time. I don't really know what you're talking about. And so we were trying to find nomenclature that actually people could respond well to, right? Nomenclature that people could actually feel like that they could relate to in their own stuff, right? Like this is always a part of the challenge when you're an engineering leader trying to communicate to non-technical folks. This is why we're working on why it's important. And what we came up with was gardening. One of my managers actually, at this point in time, one of my managers told me that I could extend this analogy further, and when that gets really bad, it's basically terraforming, because you basically have to rewrite the entire world and it basically replace the entire biosphere, was his point. But we stuck with gardening, and the idea is that was something that was a concept that was like this is going to be a really bad pun, but like a seed planted into their heads about how we want to tackle this work, right? And hopefully people understood this is why we actually needed to do it. So first, we came up with our own vocabulary. Next, we actually had to stop the world, right? Basically, we had to declare that the problems that we were facing were serious enough that we actually needed to pause and work on it, right? This is always, part of the challenge is identifying the tech debt and trying to handle it, but obviously you have to also make sure that your stakeholders agree that this is really a problem and that you are given the time and space to actually work on these things and ideally show results after you've worked on it. So the garden party was our attempt at that. We basically software sprint, asked the team, we're not going to focus on any product work, we're not going to focus on any kind of sales-driven, customer-driven work, and we're just going to focus on ourselves, right? And figure out what it is that we have to do and tackle some of these long-standing issues. To be clear, not a lot of time. A sprint for us is 2 weeks, right? So 2 weeks worth, it's not like we could actually fix the world, right? And it actually made us that we had to be creative about what it is that we were fixing. But we gave ourselves this time. And remember, we're starting from a company where we were just building product after product after product, right? In bigger companies, in more established organizations, this might have already been a given, right? But given that we did not start out with a cultural mindset that we actually have to fix these problems, this was actually a huge step. Make sure that the entire engineering team, so the entire 40-some-odd folks, were on board. We were going to do this, and we quote-unquote threw a party, right? Basically, we just sat down, started handling some of our debt. We did not actually get it mostly done. We kind of took notes along the way, made sure that we did get some of the things we wanted done, and we kind of saved everything afterwards. Now, 3. Normalize the maintenance. So once we got the garden party out of the way, once we got the verbiage out of the way, we're like, okay, how do we make this more normalized, right? Pausing everything was kind of intentionally meant to be disruptive, right? It is a signal to the rest of the company that we can't keep on doing what we're doing and actually have things be sustainable, actually have our system stay up, right? When there is an incident, where there is an encore alert, yes, that is in some cases an indication that what we were doing was not sustainable. So we knew that we can't. There's only so many times that you can press the big red button and say stop everything. So we have to fix these things, right? And so we needed to basically try to not keep on pressing the red button. At some point, it becomes less effective, right? So there's also this other bit about flexibility, right? So people recognize that, hey, if you wait for everything to be fixed at the end of the year, that's great. But a lot of times, things that you kind of notice as you were going along, as you're building out these features, that stuff you tend to forget, right? Stuff that is actually really annoying, but maybe you haven't touched that code in 3 months, so you don't remember it. So having some flexibility as to how you do it kind of continuously becomes important, right? The way we did that was basically turning the gardening practice into more of a regular thing, which ironically is actually what you do in actual gardening. You do not plant a tomato plant and just harvest it at the end of the year, right? You actually have to garden and maintain the thing over time. I have 2 engineers here, Dig and Jan. I see actually Dig in the audience. And they actually helped turn something that was a one-off, something that was recognized as, hey, we actually have to do this, into a more regular practice. We tried to align our product managers, align our tech leads to basically this process, make sure that the template makes sense for the teams, and then kind of acknowledging, particularly to the product managers, that hey, if we don't keep on doing this, if we actually don't sustain a regular cadence, then we have to go back to the party thing, and then we know all of you actually hated that. So please do not make us do that, and make sure that we actually allocate time for this. Now, so the fourth thing here is that I mentioned before, with only 2 weeks, it's not enough to get particularly major projects done, right? You have to upgrade to a new framework. If you have to go back and upgrade the database, those are longer than 2-week projects, all right? So the idea that, hey, for the bigger projects, what do we have to do, right? So once we establish gardening, then the other thing next to do is to basically start scoping out bigger initiatives. And this is kind of where, I would actually kind of point to traditional product management as a good example of how this actually happens. You establish epics. You actually spec out both the product spec and the technical spec. You start scoping out and you start creating milestones for hey, what are deliverables for every iteration of this? And you try to make sure that the same standards that would exist for a product deliverable also exist for technical deliverables. Again, coming from a world where people were just hacking stuff just to figure out what works, this is actually a huge step for us to kind of get to the point where, okay, there's actually more sustainability here. There's more thought put up front as to how we do it. And if we do all this legwork, that we actually can start prioritizing this work against the product work. Previously, because we did not do a lot of this legwork, it was actually really hard to compare apples to apples, right? Hey, this product work scoped out is going to take 3 months work, right? This engineering kind of tech debt cloud over here, we just know it's a pain in the ass. We don't know when it's going to be done, but really should work on it soon, right? And that lack of definition really made it hard to say, other than engineers just complaining, hey, we really need to fix this, we need to fix this, allowed us to say, okay, if we prioritize this over this, and this isn't take this long, then what happens is that we will push the product out by 3 months, but we will fix this issue, right? And we've actually scoped it out, and in the worst case scenario, if something does happen, right, where we actually have to start prioritizing the product first, we can stop at a milestone, we'll move to the product, right? You have to kind of treat it like basically a product deliverable for it to be actually prioritized effectively against the product deliverable, right? The nature of the impact is different, right? And this is kind of where prioritization here is not just about, hey, product cares about number of users, product cares about maybe even sales enablement, how much revenue it brings in, right? Technical debt, by definition, it's not going to be any of that stuff. And in fact, it's actually really hard to even measure how technical debt, how that actually impacts, because you're basically trying to predict the future, right? If we do this, then in the future, maybe we'll have more uptime. Maybe there will be less time spent trying to wrangle crappy code, right? Maybe the performance will improve, but you might not even see it until you do a bunch of other stuff, right? There is a lot of nuance and a lot of lack of definition, lack of clear definition of how tech debt would impact. And this is always going to be the tough part, right? This is the part where even with the right analogies, the right verbiage, even if you do get everybody brought on board to this, that this is, trying to convince somebody that, hey, this is worth a 9-month project and we need to do this. And if we do not do this, then there are some vague things that will happen in the future. That's always going to be difficult, particularly starting from an organization where a lot of the expectation is we need to release more products quickly, right? That has direct impact to the bottom line, direct impact to the business. So that I feel like is always going to be true. But with all that said, where we are now, right? So, we've made some, technical improvements to our overall systems. We're actually trying to target 80% unit test coverage across the board, and we implemented CI/CD recently across all our repos. That makes it, basically the entire DevOps side of the world is in better shape than it was before, right? Some of it, again, acknowledging that this is some of the gardening that we had to employ. We've made improvements to performance. Again, this is one of these things where it's really difficult. To try to put it within the full sphere of what a product roadmap would look like, but something that engineering owns. We understand, hey, here's where some of the bottlenecks are, and so we try to improve some of that. Fewer hiccups and more accurate sprints. So this is basically a delivery. Being able to target and understand and plan for tech debt means that hopefully we don't run into it as much as something that, hey, you didn't know that there was a landmine here, and you actually had to step on it. It's going to cost you another month to basically fix that. So not to say that we're perfect in that. Certainly there's still plenty of unknowns in the system, but we've gotten better. We have gotten some of our sprints tighter and more accurate as a result. We've also seen NPS score improve, the eNPS score, right? So employees do feel better about some of the efforts that we've put in, although I will say with the caveat that, hey, this beyond just the tech debt stuff, there's other factors, obviously, that influence how employees think about the team and about the company in general. So what we've learned. First of all, right, I go back to the idea of gardening and verbiage, that the words do matter. Finding the right analogy, making sure that people understood what we were talking about and they could relate it on their own terms, really mattered in terms of being able to convince, particularly non-technical stakeholders, why this stuff matters, right? And how should we think about prioritizing this work? Secondly, I mentioned we started out by doing something that was, in some senses, pretty simple, and fairly small, and we built up to basically a constant cadence of gardening work, and then we built up to here's some of the bigger projects, right? So, if you have to stop the world and say, hey, we're going to spend the next year just working on technical debt, chances are either you're going to be fired or the company is not going to exist anymore, right? There is a ramp up to basically getting there and making sure that if it has to be disruptive, that it is, again, disruptive at the right levels and people can understand the level of disruption, right? How bad is it going to be? And you kind of work yourself up to being able to tackle bigger and bigger projects. One pleasant thing that we found is that, the frameworks that we've built for how we think about tech debt, how we think about how we tackle it, some of the strategies and tactics that we've used, we've actually seen other teams at the company start applying the same things. They don't call their thing tech debt, right? They call it something else. They call it maybe design debt or product debt, right? There was even, I think, customer success debt, which was weird. But there are other teams that are recognizing, hey, what this going back to the idea that what this really is that we change product requirements, we change the way the product works. So of course there's going to be a lot of baggage. In technology, it comes back to bite us because it's harder to work with. In product, it means that there are extraneous things in the product. In design, it might mean that, hey, there's inconsistency in design that actually makes it really hard to use, right? It turns out that other teams actually really do have the same problems. And maybe just, again, maybe not have the right vocabulary to actually recognize it. They might not know how to actually solve it. We're actually seeing other teams start to apply the same frameworks to their work, which was pretty awesome to see. And lastly, the idea here is that the muscles that we're developing around technical prioritization and decision making are helping us mature as an engineering organization. Again, where we are right now as a Series C startup is that we came from a world where pretty much anything went, right? As long as you were able to hack something together, show that somebody wanted to buy your thing, and that's pretty much it, right? We're kind of now coming to a point where, okay, it's starting to look like a big company. If those of you who've been in big companies can recognize, okay, this is how you operate at a big company. Sometimes it doesn't make sense to do that when you're a small startup, but you basically go through this evolution of where this becomes something that now, and hopefully when we do become a bigger company, hey, like this is part of the culture and this is basically how we got there. So, maturing as an organization, that's where we want to go. Finally, here's some additional, if you want to find me elsewhere, on X, Twitter, X, whatever. I keep a blog as well, and I've been volunteering for Plato for a number of years. And with that, that is the end of my talk. Thank you.
Thank you, Alan. This was great. As a plant person myself, I love the gardening analogy. We have great questions in the Slido. Please keep them coming. Scan the QR code. I want to ask you a question before we go into the Slido. You mentioned the stop the world moment, right? But just so I'm clear, you don't do that all the time when you have to deal with tech debt, right? Like you don't. Is there a scenario where you parallelize feature building and addressing tech debt?
Yes, and that's the part about normalizing, right? When you normalize it, when you say, hey, like maintenance is a part of our sprint, right? Like some people use 20% rule. Some people will say, hey, like I'm going to allocate 2 days out of a sprint to work on this, right? That's how you basically keep from getting yourself to a stop the world scenario again. Again, nobody nobody actually likes doing that. Even the engineers don't actually like doing that.
Yeah, no,
right?
It's not fun.
But it is something that, if you actually have to get to the point where the teams say, okay, this is just a part of what we do. So instead of, say, delivering 30 story points for, product this sprint, we're going to deliver 20 because you have to spend 10 on this other thing. And once you normalize that, okay, like this is actually the amount of time we get, then it makes it a lot easier.
Awesome, thank you. First question from the audience. How did you manage resistance or skepticism from stakeholders during your transition to a balanced approach to tech debt? That's a great question.
So managing resistance and skepticism. So I think a lot of it has to do with, okay, let's give us a chance, right? Let's go ahead and see, like we'll do this stop the world thing one time, and let's see what happens, right? Like the important thing is to make sure that we as an engineering team do hold ourselves accountable. Hey, did we fix what we say we're going to fix? Do we actually see the improvement, right? Do we, we didn't explicitly measure this, but what I looked at was like, well, what are the incidents? What's the number of incidents that kind of cropped up before and after, and what is the nature of those incidents, right? How long did it take for us to deliver? We actually measured for us the lag time between a commit and a deploy before we went to CI/CD, because we wanted to know, hey, does it take us 3 days to deploy? The latest the latest version of the app, and if so, why is that, right? Because the QA cycle kept on getting longer. Well, why did that happen? It's because, hey, the quality isn't quite there, right? We didn't have the right tools because we were burdened by all this debt and all this stuff that people didn't see coming. So those were some of the ways where I could try to quantify, hey, here's the impact that we had by doing this. Hey, we probably need to do more of this, and you should want us to do more of this. I think that once we were able to hold ourselves accountable and show what some of that actually ended up looking like, people were a lot less skeptical. So that was kind of nice. Also, some of them were just straight up telling me, hey, like, you're talking technical mumbo jumbo over there, even with the gardening stuff. I have no idea what you're talking about, so sure, go do it. I'm like, great, you trust me.
Awesome. So it sounds like you used time as a leverage, a currency, explaining how the fact that you're addressing tech debt reduces feature development time. And there's a question from the audience: is how you measure ROI for working on technical debt, and I feel like that's
time is definitely one of it. Like quality metric in terms of number of bugs, right? Number of incidents. Again, like that time, like how long does it take for a release to go out? That's another valid, measurement. At larger scale and at bigger companies, you would also look at performance, right? So, traditional performance, either basically how much load you can handle, like time to first paint, if you're talking about kind of front-end performance, right? There are other aspects that you could basically measure and say, hey, like we've been able to improve on a lot of that stuff because we started tackling some of this debt. So some of those things I think are also legitimate ways to think about, again, how do you hold yourselves accountable to putting all this time on tech debt?
Awesome. And can you cite some instances where addressing technical debt directly enhanced product quality, user experience, or overall business outcomes?
Yes. So one instance that stands out to me and that is kind of top of mind for me is that we came from, again, like going back to the scenario where we came from an app that was meant for teachers to build their own curriculum, and now we're changing it to, okay, teachers are using the curriculum, but it's authored by somebody else, Turns out when you do that, when you build that first app, it's a lot of edit controls, right? Like that is a form of both product and technical debt, where it's like, well, the way the edit controls were implemented, it basically got splatted 20 times on the page. Because that's the way it was implemented. It was just easy to say where a teacher just adds a section and it's just you're going to splat another basically edit control in there, right? And you can imagine you got 20, 25 of them on a page, the entire thing starts slowing down, right? Like there are actually real performance costs to doing that. And so being able to first measure, right? So that was one of our technical debts, right? It's like, hey, being able to observe and measure kind of what the performance characteristics were, and then recognizing, okay, you know what? Most of our use cases are actually around not, technically from a product design standpoint, yes, you could, you could try to put the entire thing in view mode, but in reality, there was also still a bunch of edit controls underneath the page, right? Like you still instantiated all that stuff. You still are handling all that code, right? So it's like, okay, that probably isn't going to work. So let's figure out technically how we solve for this. And by doing that, I think even on one or two of the pages, we like increased performance something like. In one case, we actually removed a really bad regex, and we actually increased performance like 5,000-fold or something, like 5,000%. Went from, because bad regex turns out takes a second, good regex turns out takes 3 milliseconds. There's going to be a huge difference in performance.
Yeah, totally. I've experienced that. And you've kind of mentioned it, but how do you prioritize tech debt, and how do you allocate time for maintenance tasks, and how much? And I think the question is like, is it something every sprint? Is it the same amount of time, or is it a case by case?
I think for the smaller learning tasks, doing it by sprint, and we actually found out doing it by team is actually quite powerful. It's kind of the construct that allows teams to also buy in and to spend time to doing it, right? Part of the maybe less appreciated challenge of even tackling that is sometimes your engineers actually don't feel like it either, because they're going into the muck, right? They're like, hey, despite what I said in the beginning, right? Sometimes you do look at code that's like 6 years old, and you're like, what was this person thinking, right? And sometimes that means that, hey, like if you're in the moment, okay, let me be incentivized. Like I'm going to allocate some for myself. I'm going to go try to fix it, right? If you say, you know what, I'm going to put it through some prioritization process, revisit at the end of the quarter, you're never going to get back to it. Right? So I think part of it is having it be local to the team, right? And most teams do pick somewhere in the 20-25% range in terms of the amount of time they're allocating for it. And in prioritization, I would say you don't have to be perfect, right? Again, this part of it is basically motivating your team to tackle these things in the first place and making sure your stakeholders understand, right? But generally, I would say the bigger projects become, again, architecture. It's like, hey, I actually have to allocate a team here, a group of folks here to work for 6 months to fix this thing, and then other things here at the team level, they can prioritize amongst themselves, right? There's going to be a blend of things, but getting, part of the architectural exercise was basically doing enough homework and legwork so that you can actually even prioritize in the first place, right? You can prioritize because you can tell, hey, this is going to be a 3-month project. I can prioritize that against other product 3-month projects and figure out what is more important. So doing some of that legwork really helps.
And how do you motivate these engineers? Because nobody wants,
yes.
Working and cleaning up someone else's code is not the best part of software engineering.
Yes, I if I'm honest, and I guess the theme of this conference is no BS, sometimes I rely on engineers who are so pissed off at what they see that they can't help themselves, but like they're gonna go and they're gonna fix this thing. Right? And sometimes that's a really powerful thing, right? Not everybody's going to be doing that, and sometimes tell them, hey, like maybe you're taking this a little bit too far. You're working nights and weekends. I don't want you to, right? But in terms of like, if you want, again, like sometimes you get people so pissed off. It's like, hey, I really want to do better here. I want us to do better, and I really want to fix this thing because I've been building product despite this damn thing over here. So I'm going to go do something about it. I feel like, and again, that cannot be the only person who does this, but you can leverage that, right? Hey, use that energy and get the rest of the team on board, right? Try to motivate and convince them, hey, like that attitude is the right one. Go get pissed off at your colleagues, go get pissed off at the fact that like the code could be better, and go fix that.
That's a great reframe. Okay, we have time for one last question. From your experience, what is the biggest difference when it comes to handling tech debt at a startup versus a big company? And if you can share some concrete examples.
Yeah, I would say, so I was at, previously at Google, at Square, when it became a big company. I would say a lot of the stuff I talked about today is almost a given when you're a bigger company. It's like, oh, of course you take 20% to do tech debt and do other things. And really the big difference is that you get to do that in part because the urgency of what matters and what you're trying to do to like thrive as a business is much different in a bigger company. You get to have that allocation. You could even spend 40 or 50% time. You could probably stop the world for a month or 2 months, because I've done that, and it turned out it didn't matter that much, right? Like there is the the prioritization isn't quite there, because you actually don't have a driving force on your side as you do at a Series B, Series C startup. You're like, go build this thing or we might die. Right, and so to me, that's kind of the biggest difference in the thought process. It's almost a given in a bigger company. At a smaller one, you actually have to build it yourself. Like I said, current examples. At Google, we spent, I think, good 4 months refactoring an app. Turned out it didn't matter, because we were going to refactor again, like literally right afterwards, we were going to refactor it again. We went from a legacy front-end app to a pseudo-legacy Google Closure app to a Google Web Toolkit app within a span of 8 months. The thing in the middle literally didn't matter, because we would refactor it and then it would just die, because we knew we were going to refactor it immediately afterwards. And it turned out it didn't matter, right? From a company priority standpoint, you could afford to do that. At a small company, like I said, it's almost like every piece of tech debt needs to be prioritized, needs to be basically discussed, right? Because you are taking away feature time and product time, and that may or may not actually matter to the company bottom line and whether the company will thrive. So that would be a discrete example.
Gotcha. Well, thank you so much for your time, everyone.
Thank you.